Here we go. Let's graph some curves using some calculus and some pre-calculus kind of stuff. We're going to take some functions and go from their equations to the graph, all right? So, some things to remember as we do this here. Don't forget your pre-calculus stuff. If you can easily find intercepts, asymptotes in behavior, stuff like that, then use that to help you get a better picture of the graph without getting too crazy. Once we do that, then we're going to look for the first derivative and the second derivative if we can to see if they're zero or don't exist, because that tells us our critical points, all right? And then we can also use that to find our intervals of change. They're increasing and decreasing. Then we're going to find some extremas and inflection points using those critical values, sketch the curve, and fill in the gaps, all right? That's where we're headed, all right? Let's try that out. So here we have a function. We have a fifth degree function. This is an odd function. So remember that odd functions their end behavior will go in opposite directions. Normally, like plain old x cubed will go up to the right and down to the left. But when it's flipped, we know it's going to go up to the left and down to the right. So that's where we're headed, all right? Something we also know from this here is when x is 0, y is 5. So we can plot that point there. So and this is just an approximation. So we'll put that point in there. That's easy to find. Okay. So now that's about it. We could try to factor this thing, and I just don't think it'll work very nicely. So we'll stay away from that. We can't really find any zeros easily, and we're not too worried about that. We're just looking for a rough sketch. So let's find the derivative here. So we're going to find f prime of x. And we end up with a fourth degree derivative there, and just using the power rule, not terribly tough. Now we want to set this equal to 0 so we can solve it. So we can factor here. We can pull out a negative 5x squared. And when we do, we end up with that times x squared minus 2x minus 8. And we're going to set that equal to 0. All right. Get rid of this little equal sign here. How about that? And so we can factor a little bit further. I think this thing will factor into x minus 4 times x plus 2. All right. Then where's our zeros there? Well, our zeros happen, our critical values happen at the zeros here. So x equals 0 for the first one, and then 4, and then negative 2, okay? So there's our critical values. We'll call them our CVs there. We can go to make a number line here for f prime and put our points there. We've got 0, negative 2, and 4. We're going to test these values here. So let's pick a value over here like negative 3. And if we plug in negative 3 here, we get a negative 3 squared gives us positive times a negative. So that guy's going to be a negative. Plug in negative 3, we're going to get a negative term there. And plug in negative 3, we get another negative. And so we have a negative times a negative times a negative. And that's going to give us a negative in the end. All right. So we got, that's going to be negative. And plug in a number in the middle here. We've got like negative 1. So plug in negative 1 here. Let's see what we get. Plug in negative 1. This is going to be a negative term. Plug in negative 1 there. That's negative. Plug in negative 1 there. That's positive. All right. And so negative times a positive is going to give us a positive number, right? Because those two negatives are going to multiply to a positive. Okay. Plug in 1. How about a 1? Let's go with a 1. That's in between those two. You're going to get a negative. You're going to get a negative and a positive. All right. So that's going to be a positive there. And then how about if we plug in something like 5? Plugging in 5. By the way, notice that we're doing this in the factored version. If we did it up top, it'd be more difficult. So, okay, we get a negative there. We're plugging in 5 again. 5. Negative 5 times 5 squared is negative. Plug in 5, positive. Plug in 5, positive. So this is negative times positive times positive. That is going to give us a negative number. Okay. There you have it. Okay, so that gives us some increasing and decreasing here, right? Okay, so we have decreasing because it's negative, increasing, and decreasing. So 0 is not going to be a minimum or a maximum, right? Looks like it's going to turn out to be an inflection point probably. But we have here, since this is decreasing, and then increasing, and then increasing and decreasing. So -2 is going to be a minimum, and 4 is going to be a maximum. All right? So there's some useful information for us to know. So if we look back at our graph here, we can know that we already have our y-intercept of 5, so we know we're going to be going up. All right? Just put some little arrows for now. And we know that this one's going to be increasing coming into 5. Okay? And we're going to have some special values at -2 and 4. All right? So -2 and 4. Something special is going to happen. And at 0. So, all right, so let's go from there. How about some second derivative? Let's see if we can get that second derivative easy. And we can know a little bit about the inflection. Now, since this is a fifth degree, we know it's a polynomial. We know it's going to be defined everywhere. That's pretty much enough, okay? So actually, let's see if we can graph this without the derivative, all right? So we know that we're going to have a maximum, and we're not worried too much about what that maximum is, but we said that we're going to have a maximum at 4. So somewhere up here we got a local maximum. And somewhere down below we've got a minimum. We don't necessarily know if it's below the x-axis or not, all right? But we know that at -2 we've got a minimum. I'll put it below just for kicks, all right? Since this is a maximum, we're going to go concave down here, and that works for what we're saying down here. We said we know we're going down to the right because it's an odd function. Over here at the other end, we know that this is going to go up, okay? And so this is going to have an inflection point somewhere in between here, and let's go ahead and find that with the second derivative. But we know it's going to curve down, have an inflection to change there, and curve down and around there, all right? But let's go ahead and find that inflection point real quickly with the second derivative, all right? So our second derivative here, let's go find that. We're going to take, looking back at this one, let's find our second derivative, f double prime. And we're going to get a nice cubic here like this. And so if we set this equal to 0, we should be able to factor it. And all right, we've got a quadratic there we're going to need to factor. And I'm sure hoping it factors. I'm thinking we got a 2x and an x. And something that multiplies to 4. Actually, I caught a little mistake. Do you see that there? 9 factors out of negative. Since we factor out negative, we should have a negative. All right, so those signs will be negative there. And so I think that's going to help us out there. Yeah, just with a little trial and error, we can see that we've got a -2 times a 1. No, -2. Let's make that a -2. Speaking of trial and error. Sometimes trial and error is more error than trial, you know? But that's all good. So we've got -2, and if you simplify this, you'll get the -3x in there. So, all right, that'll do it for us. And so this gives us our zeros, our critical values for x, f double prime. And so we get that at 0. And we have -1 for that second term there, and we've got a 2. These are our possible inflection values, all right? Basically just our critical points of the second derivative, okay? So we can do a number line for this. Here's our number line for f double prime. And so we can plug in -2. Let's try -2, and let's see real quickly. With -2, we're going to get a positive, going to get a negative, and a negative. So that thing's going to be a positive, okay, which means concave up. We have, let's go with like a -1/2. -1/2 is going to give us a positive. -1/2 here is going to give us a +1, right? -1/2 is going to give us a negative. So this is positive, positive, negative, we said. And that's going to multiply out and give us negative, which means concave down. If we plug in a +1, let's go +1 here. That's going to give us a negative, positive, and a negative. And that's going to be a positive, which means concave up. And then we're going to plug in like a 3. 3 gives us a negative, positive, positive. So that's going to be a negative, concave down. All right, so we have inflection points at -1, 0, and 2. They're all inflection points. All right, so -1, 0, 2. Those are inflection points. So let's go check that out on the graph. -1, 0, and 2. Is that what we said, I think? So -1, we're going to have an inflection point somewhere in between these 2 points. At 1, all right, 0, sorry. 0 is going up. And then at 1, we're going to have an inflection point, all right? So why did I put it there? Okay, well, I know that this is concave up. And if we look back at that, we have concave up. And then we have concave down. And we have concave down actually from 1 to infinity. So let's look at that again. Actually, sorry, 2 to infinity. I think I put that in the wrong spot. Let's go back and look at that. No, well, I guess we got it right. So 2, that's right here at 2. All right? And then it was concave up. From 0 to 2, it was concave down. From -1 to 0, concave up. From -1 to infinity. So something like that, not pretty. In reality, it probably actually goes higher than this because it's not going to make this little short squatty thing. But that's all we need there. There's our graph, and that is the graph of f of x. All right, let's try another one that's not a polynomial. Let's try some pre-calculus stuff first here. We got f of x. I don't know how we got a sneaky little z here. Let's make that z into an x, a beautiful x at that. Try some pre-calculus stuff. We plug in 0, and we can see that f of 0 is 0. That gives us a reference point, all right? And we'll go ahead and mark that on our graph here. Let's go with f of 0 is 0. That's a good deal, all right? So now we've got to go to the calculus stuff and find some derivatives here. So let's find f prime of x here. Oops, f. And we'll do our power rule. Dropping those powers and subtracting 1, we get this here. And, all right, so we want to set this equal to 0. Let's find our critical values here. So in order to do that, let's maybe factor. Factor out x to the 1/3 because it's the smallest. And let's take that negative or positive 10/3 while we're at it. Why not? And so now we can solve this pretty easily. Set this equal to 0. The first one's just going to be 0. We see that x to the 1/3 minus x minus 2 actually is 0. So add 2 to both sides, and we'll see x is 8. Okay, so we get 0 and 8. Here x is 0 is our critical value. And so we got our critical values from the first derivative. X equals 0 and 8. Let's go ahead and find our number line here now. F prime. And our critical values are 0 and 8. And let's plug that in to our derivative. And we go either form, this one or this one. You choose. Well, how about this one down here? I'm going to go for that one. Okay, so let's pick a number like, well, these are cube roots. So something like a 1 would be nice, or a negative 1. And so if I plug in negative 1, cube root of negative 1 is negative 1. So this is negative. Cube root of negative 1 is negative 1. So this whole thing is negative. That makes this positive. And that's going to be increasing. So from 0 to 8, plug in positive 1. Positive 1 is that. That's going to make this positive. This can make this 1 minus 2, which is negative. So positive times a negative gives us a negative. So between 0 and 8, we have negative. Then we have up here at 9, let's pick, how about we pick 27? Positive 27, put it in there. That's going to be a positive number. Positive 27, cube root of 27 is 3 minus 2 gives us a positive number. So everything's positive there. All right, so we see that we're going increasing, decreasing, and increasing. All right, and so that means we've got some minimums and maximums. So 0 is going to be a max, 8 is going to be a min. Okay, that's good news. So jumping over here to our graph, and we know at 0 we're going to increase into 0, and we're going to decrease out. And then somewhere over here at 8, we know we'll be increasing. All right. So there we have it. By the way, we should have mentioned this is a cube root, so we need to stop and think, are there any values that are undefined? And the answer is no. Cube roots are defined for any real number. All right. So you can put negatives in there, you can put positives, so on and so forth. All right. So let's try this out here. Next up, find the second derivative. So let's find f double prime of x. All right. Using our, let's see, using this guy right here. Okay. So let's use our power rule again. All right, and so we get this exciting negative powers here. So let's go ahead and factor the smallest one out and see what we get there. And when we pull out 29 x to the negative 2/3, that's going to leave a 1x to the 1/3 and a minus 1. All right, there you go. That's not too bad. So if we clean that up, one more step, we're going to get, something along this line. And there's our derivative there. So we set this is the second derivative actually, set this equal to 0. Okay, and we have some possible inflection points. Notice that x cannot be 0 because that would make the bottom 0. 0 to the 2/3 power is 0. And what makes the top 0? That would be 1. And that's it. Okay, so 1 is a critical value or a possible inflection point, and 0 is a possible inflection point. Okay, so we have our possible inflection points here, PIVs. So we have f double prime, and so that was at what, 0 we said, and 1. All right, and so testing the values here, we have looking for some inflection or some concavity. Okay, we've got plug in like a negative 1 here. All right, so negative 1, let's go back to here. Let's go back to this one here. All right, so plug in negative 1. This is going to be a negative on top because the cube root of negative 1 is negative 1. This is the square root of the cube root, so this is going to be positive, all right? So that's going to be negative on the whole thing, all right? And then plug in, let's say, a half. Plug in a half, well, this is going to be less than 1, so we'll have negative on top, and we'll have positive on bottom. So that's going to be negative. Plug in something larger than 1, let's say, because we're talking cube root, let's talk 8. Plug in 8. 8's cube root of 8 is going to be 2, so this whole thing is going to be positive, 8 here is going to make it positive, so that's positive. So we notice that there's no inflection point right here because it doesn't change. We already know that's a maximum, not an inflection point. And we have an inflection point at x equals 1. That's our only inflection point because the concavity changes. So to wrap this up here, we can say this. We know that we are, let's see. We know that we're decreasing out of here. We've got an inflection point at 1, okay? So we're decreasing, concavity changes, and it's going to be concave up. And we know we have a minimum at 8. So it's going to be going down, concave up, go through there, and going up forever, okay? And then, so we have concave down coming out of here. All right, we'll leave it there, and we'll make a second video for the next ones there.